There's a Yogi Berra quote that I just like. Yogi Berra said, "You can see a lot just by looking." And it's so traditional Yogi Berra because it makes absolute sense if you think of it in a certain way. And I think it relates to some chemistry experiments or demonstrations too. Do you ever do a demonstration or an experiment and the students say, "What did you do? What did I see? What was that?" It's as if they saw, but they didn't see. And so I want to do a demonstration that can be used in a lot of different areas in chemistry. It's a great introductory chemistry demonstration just for observations. So as Yogi Berra would say, let's see what we can see just by looking. I have some copper chloride, and before I do that, I am going to put some gloves on here, just to be sure that when I pour that, I don't get it on my skin as well. I have 1 molar copper chloride and a large hydrometer cylinder here, and I'm going to fill that just about half full. The amounts are not critical in this demonstration at all. So just about like that. So I have some 1 molar copper 2 chloride, and I'm going to add a piece of aluminum foil. And I'm going to roll that into a cylinder, just a very loose cylinder, so that it'll fit down that hydrometer cylinder. And the first thing we're going to do is we're just going to watch. And think about all the observations that immediately start happening. What do we see? Bubbles immediately, a color change, blue going, oh, smoke, oh my goodness. Okay, and there's some red solid, and that red solid is falling to the bottom. It's really bubbling pretty heavily there. I can get that aluminum foil. It's almost as if the aluminum foil is disintegrating. I'm going to push that in a little bit. So it's disappearing. So what we have here, we obviously are getting quite hot. We're going to turn on this thermometer. It's in Celsius, and let's see where we're at. We're at 68, 72, 74. It's getting quite hot. It's almost boiling. So we have a lot of observations, clues, if you will, as to what's going on here. In the reaction of copper 2 chloride with aluminum metal, what's going on? I'm going to rinse this thermometer so that that red solid doesn't stay on there forever. So let's look at what are the signs of a chemical reaction, what's happening. We saw some gas almost immediately. That's probably a little bit of hydrogen gas from the reaction with the aluminum. The aluminum disintegrated, so clearly that's a sign of a chemical reaction. We also got this red solid. I can remember doing this with students in my class, and they would do it actually on a small scale on their benchtop, and they would get this red solid, and they would go, well, what's that red solid? And you would look at them and say, well, what do you think it is? And the first person, of course, always says, it's rust. I think it's rust. And you go, well, rust, how could we have rust in there? We've got copper 2 chloride, copper ions, chloride ions. We've got aluminum foil. What's rust? Well, rust is iron. Did we have anything in there that should rust? No. So what else could it be? And they think for a little bit, and you go, well, what did we start with? We started with copper 2 ions and aluminum foil. So what might be reddish brown, almost kind of a coppery color? And you can almost see, this is a great one, again, a great first demonstration or first experiment for students, because the observations themselves are the clues that lead them to understand the chemistry. And they go, reddish brown, copper. You can see the light bulb go off in their heads that they've figured it out all on their own. So we have a pretty simple, what we call chemical reaction here. We had a lot of the traditional signs of a chemical reaction. We had a color change, we had gas, we had a solid, we have heat that's produced. It's actually steaming. The reaction's pretty much over. I mean, the aluminum foil reacted. We know we started with aluminum metal, and we reacted that with copper 2 chloride, which was in aqueous solution. And we think that we got copper metal, so we'll write copper solid there. Now, what's the other product? Well, the aluminum foil itself disappeared, so it was converted to something that's soluble, which means we pretty much had to dissolve, or actually oxidize, if you will, the metal to give aluminum cations. And so if we have aluminum 3 cations that are produced, then chloride ions would be the counter ion there. And so in order to balance that, we're going to need 3 of these, and 2 of these, and 2 of these, and 3 of these. So we have 2 moles of aluminum, 3 moles of copper chloride, 3 moles of copper, 2 moles of aluminum chloride produced. Now, it looks like the chloride ions aren't involved in this reaction because they're just dissolved in the solution. So we could write an alternative reaction or equation there, which would be what we call the net ionic equation. We're going to keep the coefficients there. And that would be the net ionic equation. So according to that ionic equation, the identity of the copper salt that we used shouldn't matter. In other words, it shouldn't matter whether I had copper chloride or I have some copper sulfate. So I'm going to try it with some copper sulfate just to prove that that single replacement reaction, that the identity of the anion doesn't matter, because that's what we teach our students. So this one, I'm going to pour it just about a third full rather than a half for a reason that's going to become apparent. So I'm kind of leading you on here a little bit in terms of what you're going to see. And again, I'm going to take a piece of aluminum foil. I'm going to wrap it, roll it into just a very loose cylinder. I'm going to add that. Now, this reaction was very fast, remember? So you got to watch, because it was over real quick, right? So I add that aluminum foil. I add it to my copper 2 ions. Let's take this out of the way here a little bit. And there it goes. The reaction is really fast. No, wait a minute. It's not. It's not reacting. But we wrote the equation down. 2 aluminum and 3 copper 2 ions. The chloride ions don't matter. But nothing's happening. Why is that? I love this demonstration for a lot of reasons. It's a terrific introductory demonstration. But as with a lot of chemistry, or with life, there are layers to it, like peeling an onion. It turns out that it's not quite as simple as we first imagined, that we need something else there. When I have copper 2 sulfate and the aluminum foil, nothing happens, and we can wait quite a long time. Why is that? Well, you know, in this reaction of aluminum with copper chloride, we're actually also talking about what is called the activity of the metals, that aluminum is a more reactive metal than copper. And so that reaction takes place in the forward direction, and we get copper metal being produced. It's because of the activity of the metals. But it turns out aluminum is kind of unique. You know, aluminum is a very reactive metal, yet we build airplanes out of aluminum. How can that be? It's because aluminum is protected by an oxide coating that's almost invisible, or is invisible. And that oxide coating basically adheres to the metal so strongly that it protects the underlying metal. And so there was something in here that's not in this one, and that's the chloride ions. Even though it appears that the chloride ions are not involved in the reaction, you in fact need the chloride ions. So what I'm going to do is add some sodium chloride, and I'm going to fill it about half full, and then I'm going to try to mix them in here. And the nice thing about using a hydrometer cylinder in a classroom demonstration is it's really visible. It gives you that height. It's not just something that's small on the bottom of the bench there. But the drawback is that it's a little difficult to mix reagents once you've got them in there. So I'm going to go ahead and add that. And right now I probably still have 2 layers. I'm going to pull that up, but now our aluminum foil is a very convenient stirring rod. And so what I'm doing here is mixing the copper 2 sulfate and the sodium chloride. And pretty soon, I should begin to see some reaction. Are we seeing anything? I'm looking at it here. I don't know if you can see that up close, but there's a little bit of red beginning to show on the aluminum foil. Clearly, we're a little slower here than we were before. I'm going to add that right down in there again. Do you see? Now we see some metal being produced. We're getting a little bit of bubbles. We can tell that because it's actually floating to the surface. Actually, kind of when it does it slower, it's almost nicer because it's slow motion by itself. Clearly, the reaction is now taking place, not as fast as the other. That might have to do with mixing and so on. So the chloride ions appear to be necessary for the reaction to occur, even though if we write the net ionic equation, it's not involved. And this is getting pretty hot. We're up to about 40 degrees, 45 degrees or so right now. You can see that now we're starting to really go to town here. And I think that's probably just because of the inefficient mixing in that relatively tall hydrometer cylinder. Now you can really see the red solid. You can see that the aluminum foil has almost disappeared. There's some that has settled to the bottom there, the gas and so on. So what we've demonstrated with one very simple demonstration are a number of pretty important topics. First of all, and not to be in any way put down, is just the idea of looking and seeing and observing, because a lot of students don't really know what they're looking at, and you need to teach them observation skills in the chemistry classroom. We talked about signs of a chemical reaction. We talked about metal activity. If you talk about oxidation and reduction, you could, of course, relate that to this topic. You can use it in a number of different places in your curriculum, just depending on where it fits at a particular time. One other topic or concept, if you will, that is a part of this demonstration had to do with the role of the chloride ion, because we said that the chloride ion didn't appear to be involved in the overall chemical reaction based on the net ionic equation, but yet the chloride ion was necessary for the reaction to occur. It made it go faster in the case of the copper sulfate. And we can't prove it, but we have reason to believe that that chloride ion is still there. And you could actually do some tests to show that. So a substance or a chemical that promotes, that increases the rate of a chemical reaction, but that isn't used up in the reaction is called a catalyst. And so we have a very simple demonstration that can be used in many different parts in the chemistry curriculum, just depending on what you want to emphasize. You may think, well, if I did that at the beginning of the year, why would I do that at the end of the year too when I'm talking about catalysis? But students don't mind if they see it again, because they go, oh, I remember that one. That's what's going to happen there. So many of your favorite chemical demonstrations can be used in a variety of spots in your chemistry curriculum. Another interesting thing, and this is the last point on this chemical demonstration, has to do with the role of the chloride ion. This reaction has been known for a long time, this particular demonstration, which, by the way, we call foiled again because of the reaction of the aluminum foil with the copper. But scientists are still arguing about the exact role of the chloride ion, and isn't that great? That we're doing a very simple chemical reaction that has probably been known for ages, since both aluminum and copper have been known for a long, long time, probably since ancient times, certainly in the case of copper. But scientists still don't know exactly what the chloride ion does. They think that it permeates that oxide coating on the aluminum metal and then increases its reactivity. And we know that chloride ion actually also does that to iron and to steel and increases the rate of corrosion of iron and steel. So there are a lot of chemistry packed into just a very simple introductory demonstration.